Hello viewers, I am Dr. Neha Singh, associated with ABES Engineering College, Ghaziabad. Today, we'll be discussing the topic ultimate analysis of coal. As we have discussed in the previous videos, that the classification of coal, that is peat, lignite, bituminous, and anthracite, it is based on different kind of analysis. And both the analyses are known as proximate analysis and ultimate analysis. Proximate analysis we have already discussed. So let's discuss ultimate analysis of coal today. So ultimate analysis can also be called as the elemental analysis because it includes the estimation of carbon, hydrogen, sulfur, nitrogen, and oxygen. So what is the significance of ultimate analysis or elemental analysis? The amount of carbon, hydrogen present in the fuel determine the calorific value, contribute to the calorific value. So the more carbon and hydrogen percentage is present in a fuel, more calorific value will be given by the fuel. While sulfur and nitrogen's presence in the fuel will depreciate its calorific value because it comprises of volatile matter which does not contribute to the calorific value. So let us start with the determination of carbon and hydrogen content in the coal. So in this method, there is an assembly. I will show you. We use it to determine. You can see here, this is an assembly. Here the furnace is present where the fuel is being burned. So here we will take a unit gram of coal, that is 1 gram of coal in pulverized or powdered manner, and we'll keep it here in the furnace. While we'll associate with this assembly with two tubes, you can see two U tubes having, one of them is having anhydrous calcium chloride, which is a hygroscopic salt, and second is KOH potassium hydroxide solution. So why these are taken into it? You can see over here when the combustion of carbon is having occurring, so it is combining with oxygen. So we can say when the combustion of a carbon is occurring, it means oxidation of carbon is happening and it is converting into its oxides. You can see CO2, right? So when carbon is combusted in presence of air, it forms CO2. Similarly, hydrogen forms water. So here in this reaction, when we are going to burn our coal sample which we are analyzing, all the carbon will be converted into CO2 and all the hydrogen will be converted into H2O. Now you can see the significance of these two tubes. You can see over here, CO2 is being reacted with KOH and forming K2CO3. That means KOH has a tendency to absorb CO2. So here, KOH is used to absorb CO2, all the CO2 which is formed during the combustion of a given coal sample. Now, similarly, you can see calcium chloride is an anhydrous salt. It can absorb water. It has a great ability to absorb water. So what it will do, it will absorb all the water and form the water of crystallization over here, which is coming from the burning of the coal. So all the hydrogen, which will be converting into H2O, will be absorbed by the CaCl2 tube. So let us start with the topic. Now, we have maintained this assembly. Before starting the process, we will take the weight of calcium chloride tube and KOH tube. Suppose it is X1 and it is Y1. Now, after taking the weight, we'll put our coal sample here and start burning it while providing the pure oxygen supply from here so that combustion takes place. The fuel will start burning and it will be converting into CO2 and H2O. So all the CO2 which is present will be absorbed into this KOH tube, increasing its weight to suppose Y2. And similarly, all the water absorbed by CaCl2 will be increasing the weight of CaCl2 tube. Suppose its weight increases to X2. Now, taking the value of X1, X2 and Y1, Y2, that is increase in the weight of KOH and CaCl2 tube, we can find the percentage of carbon and hydrogen with this given formula. So for the calculation of percentage of carbon, we will use Y1 minus Y2, that is increase in weight of KOH tube, right? Into 12 because the weight of carbon is 12 upon 44 because the weight of carbon dioxide is 44. Upon weight of coal sample, that was 1 gram. Why this we will take? Because we are determining the percentage of carbon in 1 gram of coal sample and we'll multiply it with 100, we'll get it in the percentage. Now, similarly with the hydrogen, we'll take the increase in weight of calcium chloride tube, that is Y2 minus Y1 into 2 weight of hydrogen upon 18 weight of water upon weight of whole sample, that is 1 gram into 100. This is how we will take out the carbon and hydrogen percentage. So if the carbon percentage is beyond 80%, then the coal will be of premium quality. Second, nitrogen content. So the nitrogen content estimation is important because more nitrogen present in the coal will form the volatile matter and will decrease the calorific value of the coal. So here we are going to calculate it for the same purpose. Nitrogen present in coal sample can be estimated by Zeldol method. Zeldol method was given by Zeldol, who was a famous chemist. He maintained apparatus, special apparatus for this, which you can see the picture, which is known as Zeldol apparatus. Yeah, Zeldol flask. So what we will do over here, in this round bottom flask having long neck, it is known as Zeldol flask, we will add 1 gram of whole sample, we'll add H2SO4 and K2SO4 as a catalyst, and we'll heat it in using this heater over here. All right. So what will happen during this process? All the nitrogen present in the coal will be converted into ammonia. So here we can say the reduction of nitrogen is taking place. All right. Now, after some time, when this solution will become clear, we'll understand that all the nitrogen has been converted into ammonia. Now, ammonia being a gas will be trapped over here and will be passed into this tube having zero point 0.1 normal H2SO4. So 0.1 normal H2SO4, why we are taking? Because ammonia here is a gas. You cannot store a gas for a long time because it has the tendency to diffuse. So we will lose ammonia if we keep it here for a long time. So what we do, we have to ascertain its value so that we can understand how much nitrogen is there. So all the value of ammonia will give you the value of nitrogen. So what we will do, we'll do a titration, neutralization titration with 0.1 normal H2SO4 over here. So all the ammonia will be passed into H2SO4 because ammonia is a basic gas and H2SO4 is an acid. They'll be neutralizing each other. But here acid is taken into excess, right? Suppose 1 liter of H2SO4 is taken over here. So I don't think so 1 gram of coal must be having that kind of a nitrogen that will make ammonia enough to extinguish or neutralize it properly, fully. So some of the ammonia neutralizes it and rest of the excess acid remains in the form of acid. Now we have to ascertain how much ammonia was there. So 1 liter, out of 1 liter, the part of acid which is excess, which is still excess, we can ascertain it by subtracting it from the total value. So what we will do is, we'll take this 0.1 normal NaOH and we'll titrate this solution with this. So only the excess acid present over here, which is not utilized by ammonia, will be titrated with the NaOH solution, and rest of it will be neutralized already by ammonia. So let's say the total volume is V1 and the volume which is used for neutralization is V2. So here in this formula, we'll put the volume. Volume of acid used is equal to V1 minus V2. That is 1 liter minus, suppose 200 liters were used. So 1000 liters minus 200 liters, 800 ml will be here. Normality was 0.1 normal and weight of whole sample taken. That is 1 gram. 1.4 is the simple analysis of 14 upon 100, right? In the percentage of calculation. This is how we will take out the value of nitrogen percentage. Coming next to the sulfur content determination, similar to nitrogen, sulfur also does not contribute to the calorific value of the fuel. So therefore, lower will be the quality of sulfur, content of sulfur in the coal, better will be the quality. So here what we will do, we will use a method known as bomb calorimeter. This apparatus you can see is known as bomb calorimeter. What we will do, here we'll take 1 gram of coal and just seal this equipment, and these are the electrodes attached to coal sample. We'll attach to the battery and electrocution of the coal will be done. While the fuel is getting electrocuted, this steel bomb absorbs all the heat coming from here and transfers it into water around it, right? In this process, all the sulfur which is present in the form of sulfide, right? oxygen's presence will make it in form of sulfide, and because of the steel container is there and it is a gas, it will keep coming out in this water. So this water, after the burning of the coal, will be known as washing of the bomb calorimeter. So what we'll do, we'll open the apparatus, we'll take out this water or the washing of bomb calorimeter, and we will add barium chloride into it. Why we are using barium chloride into it? Because barium chloride, that means barium, when reacts with sulfur, it forms a very solid precipitates yellow color, and it cannot be dissolved even in the acid, insoluble precipitate. So here what we will do, we know that our washing contains sulfate, so we will add barium chloride, which will form barium sulfate by the ion exchange reaction, substitution reaction, and BSO4 will be formed. All the BSO4 will be having the entire sulfate, the sulfur present in the coal. We'll wash it, we'll dry it up to the constant weight, and then using this weight in this formula, weight of precipitate, suppose the weight was 2 grams, 2 upon weight of coal sample, that is 1 gram, into 32, that is weight of sulfur, upon 233, that is the weight of barium sulfate, into 100, that means for the percentage of sulfur calculation, we'll get the value of it. Now next is ash content. So ash content is taken from the proximity analysis, and next oxygen content. So everything, all the elements along with the ash included, when it's subtracted by the 100, the overall weight, then the answer will be and the remaining answer will be oxygen, right? So this was all about the ultimate analysis of coal. Thank you so much.